Hello, my name is David from David's Rebel Coding Podcast. Today we're going to talk about Canvas. There's a place on this planet where two oceans meet, a place that will humble even the bravest of souls. Before World War I, ships had to sail around the Cape of Good Hope. On March 20th, 1602, the Dutch East India Company from the Netherlands capitalized on the spice trade, enriching Europe with spices from India. Today, our spice is Chinese five spice. The United States became a nation in 1776, but they had no money. Actually, the debt, the U.S. has $38.4 trillion in debt, but the debt doesn't really matter. What matters is a term in international finance called net international investment position. And if you use this metric, which takes into account the debt, you have Japan, Germany, China, and Norway as leading the world as the world's net creditors. Now, recently in the news, some things have happened regarding oil sources, and there's been some talk about Greenland. So I thought I'd just apply this. It's just a technical podcast, so we're just really talking about Canvas and JavaScript. I'm part of the Empowering JavaScript movement. As developers, we were frustrated with ActiveX controls, Silverlight, Flash, and Macromedia Directory. The problem with all those technologies is they require consent from the user, and they opened up a potential security breach. If somebody wrote malicious code in ActiveX, they could have access to your computer potentially, which is why all of those technologies have gone extinct. And luckily, we have a way to interact for the first time since 2015 with the GDI, stands for Graphical Device Interface. So for the first time, we can do animations. We can interact pixel by pixel on an HTML page. We never had that ability to do that before. So you used to, like, if you want to do ArcGIS or GPS data, it's called, it's huge. There's 9 Landsat satellites that were launched, and they continuously take pictures of the Earth's topography all the time, and there's many more satellites than that, and they even had the entire globe was already mapped before Landsat was launched in the 50s with other types of satellites. But a lot of these satellites are the maps aren't free, actually. The satellite company owns the maps, and they're actually quite expensive. And if you work with Esri, you'll see I'm on their Esri account listing page. You're just as a creator, you're going to be paying $13.70 per year. If you want the professional, so you can actually do some things, it's going to cost you $4,390 per year. And then if you want professional, so this is more comprehensive tools and things, it's going to be double that again at $8,330. And I don't know if you have to, there's a quantity here as though this is for like per licensing fee perhaps or something. So that's expensive. That's why it was mostly governments and big corporations had the ability to work with the ArcGIS or the professional data, and still the de facto professional way to do it. But at least thankfully, because Google came around and decided to take those binary file formats that Esri uses, because you see you can't use binary with JavaScript, so they decided to flatten it out into a normal text file that you could just read using the normal DOM techniques in JavaScript. And Google's awesome with maps, right? Giving them away for free. We all rely on Google Maps to get around and search for things, and we like that. And they use Landsat satellite data. So I'm saying you can make your own, like if you're an environmental eco warrior and you want to highlight some, there's thousands and thousands of KML formatted, and you can convert your Esri GIS binary formatted GPS data into KML files and then display them really easily. Actually, it's like 10 or 15 lines of code to do it, and the costs are very minimal. So it's never been easier. So we're in a golden era of web application development where things have gotten more efficient and easier to express yourself by building web applications. So let's look at the world for a moment and think, okay, so something just happened in Venezuela. The Venezuela is where the heavy crude comes from. Now, heavy crude is not what you drive around with in your car, but it is what a truck can use. It is what ships use. So it's heavy diesel. So those big heavy engines, tractor fuel, can be refined from heavy oil. The largest two sources of heavy crude come from the Athabasca tar sands in Canada and the Orinoco Basin in Venezuela. And for some reason, the leader was helicoptered out of his country, not by choice, and those oil fields are regarded as important. And we've got 7 billion people living on the planet today, but let's just take a little bit of a history lesson to find out how things were done in the Netherlands with the Dutch East India Company. The spice trade would go from basically India over here around the Cape of Good Hope and then into Boston Harbor, where the British would unload their tea. It's mostly tea and other spices from India. Otherwise, your diet's very bland and it's very boring, so it adds spice to life. So let's load in the traditional shipping route and just see. Now, I've just created a basic, using the circle calculation to calculate that this traditional shipping lane distance, I handcrafted this. I don't know if it's accurate or not, but it roughly gives you the idea. It takes 28,000 kilometers to get from Shanghai to New Jersey. And so what happened in 1914, when the world was at war, World War I, is the U.S. took a heavy interest in making sure that the Panama Canal was successful. And this was the dawn of the age of modern globalization, where global shipping was just emerging. So they were pioneering the way. They looked at these numbers and said, "This is not acceptable. We need to do better than that." So they dug this canal. It was one of the greatest human achievements of the modern age. And we dug a path through the Panama Canal. Actually, I guess that I didn't look exactly where the Panama Canal is, but I put the line across just to calculate the route. It might not actually be in the right place. And just say that. But it saved 28% on every ship that was transporting from, still probably would have been coming from India, but here I have it coming from China because I think a lot of goods are made in China today. And it's a little farther. So the old way would go through Indonesia, go through Sri Lanka, you could pick up stuff there. And then you also had another way to go through the Suez Canal if you came up through here, and then you go through the Straits of Gibraltar and you could end up in the same place. So ships do that as well. It's like a straighter route. So actually it would probably be a comparable way to go. In this demo, I'm only showing these two ways. And then the thing is, with the global warming and the fact that the ice shield is melting, it's cutting a path through the Arctic that interests a lot of people. And it's because of the convergence of population. We got 7 billion people and we're on an exponential trajectory curve. Means that if we want everyone to have the cushy standard of living lifestyle and the expectation that we want a better lifestyle than our predecessors, then people in the know that are analyzing this are saying, hey, let's go through Canada. Let's cut through Canada. Let's come down through Greenland. Let's secure Greenland. We got 6 military bases in Greenland. Let's secure this shipping route. And look how much we're going to save. 44% from the traditional Dutch East India Company. That's huge. If every cargo ship saves 44%, and then if you can maybe gain another 6% in fuel economies with efficiencies in the engine, in upgrading the engine, maybe some electric assist on the motors or something, I don't know, or some hydrodynamic innovations, or I've heard they put some sails on some of these shipping that add a couple more percentage of efficiency, then you're almost at 50% more efficient in the trading, in the trade routes. So that's enormous. If every cargo, everything you buy suddenly takes 50% less energy, it literally means that you can have 50% more people with using the same amount of energy. So that's why it's important, I think, why this is happening, why it's in the news. And we can express this now without having to pay $4,000 a year to get the technology, just to display this. And you can do this with all kinds of things. With look, I can like if I want to look at electoral information, like I could just load in the states map. So I think I've got it in downloads here. I can take the U.S. states, select those, and then it draws them on my map. So like you can take electoral districts and look at Republicans and Democrats and find out which part of the country leans which way. And you can do all kinds of visual presentations using GPS, or it's called GIS informational systems often. And just with 10 or 15 lines of code, you can calculate distances between GPS coordinates. And it's relatively trivial. You can do it all in JavaScript. You can save your data using GenAPI directly with JavaScript, as you learned in some previous videos. But for this, what I'm advertising for here, my little advertising plug, is that if we get just 3 people to join our group today, we can start a course and we can build a gaming engine. And that's ultimately what this is about. We want to go from 2 dimensions. This is the Mercator projection, it's called. And we want to move into 3 dimensions. So in Canvas, I'll just show you a few things. So for example, you can project lines in any sort of type of projection that you want. So here I'm projecting just the normal map of my house along the longitude and latitude lines of a sort of 3-dimensional map. So that's one example. Then you can build terrain. So here's an example of using a kind of sine wave to make elevations, and then I'm just rotating it kind of back and forth, and I'm running a simulation. So you can generate terrain this way. So you can build worlds like that, and it looks quite nice, and you can shade different parts based on the elevation. That's what you're seeing here. A lot of these are just prototypes and code snippets where I'm kind of playing with some different things. Here's another, like curtains or grass. This could be like you apply physics to, Newton showed that there's just a few simple laws that can be followed, and programmatically it's quite a simple calculation just to apply force to your drawings and create kind of physics with the gaming engine that we developed. So F equals ma, simple calculation. And then basically the math is simple. You start out small, so like in high school, you do algebra, you use substitution method, and you can find the intersection between 2 lines. You learn general form, and you learn y equals mx plus b, slope-intercept form. But then when you go to college or university, you learn linear algebra, so you can go in n dimensions. And actually, you can do the same mathematics in linear algebra, actually simpler, by applying matrix transformations and then solving your equations using linear algebra. And it's actually more efficient when the computer runs and does it that way. And incidentally, a lot of the large language models are trained use linear algebra matrix transformations extensively. So if you learn it here, you'll be ahead when the world goes towards AI. Other people will be using it and consuming it, but you could be producing it, and you could be understanding what what the rest of the world is happening, you can make more informed decisions. Let's look at some more perspective projection. Okay, so our jelly eyeball is not flat. So what it means is that the light that comes into our eye, because it's a cone shape, follows Snell's law, and so things in the distance become smaller and things in the foreground become bigger, and this is called perspective projection. The sort of antithesis of three-dimensional rendering that's not perspective projection is called orthogonal projection. So a little bit of vocabulary. Vector math. This is kind of cool. So when you're rendering a 3D scene, this shows how you can parameterize the three variables of x, y, and z, and then the relative proportions of each variable can then be scaled to follow a point along a trajectory, along a linear line. You can see how that is done mathematically, and visually you can see how we're elevating, rotating this plane upwards. So you can use these and then I'm filling in the region. So you can, helps you visualize how you can create walls and things like that in our 3D rendering engine. And then some of the challenges associated with having it look decent when you're in the rendering process. SketchUp, there's the interactivity. So here I'm using the mouse to see how we can control the movement of what we're seeing on the screen. So this is being able to rotate in I forget what it's all called in airplane terminology. They use your skewing, or I forget what it's called again, but you can move in like 3 different directions, I think. Then we've got ray casting. So again, this is almost like I can move this and I can intersect those rays at a wall surface. So that's the beginning of looking at how we can go from our 2D map into a 3D world. So if you look at, another thing is like movement of a person walking. You kind of walk, so you can add a jiggle just to make it look more interesting as you're running down a hallway. This is just proof of concept kind of things. Polygons. Again, this is kind of applying some of those shadings. So we figured out how to do tiling, arrangement patterns in polygon shaped figures, and then we have the concept of the ray casting out to fill in. So you can get some really interesting textures and things like that on your surfaces or your walls that reflect where a light source might be. We have darker and lighter areas. That's 2D again. So let me reset that. And then what you often see, this is some attempts at getting a rotating cube. So it's understanding which sides they're called back face culling, or like which sides do you paint and which do you show, and which, so you have to work that out. And here's an attempt where I'm trying to figure that out. I think at this point I haven't quite done it correctly yet, but I'm getting there. I'm starting to understand how that works, and these are the orthogonal projections out from the surfaces. I think there's some better cubes. That's the one I just did. So there's another one here. This is one where I'm using the mouse. I can rotate with the mouse, and I haven't quite figured it out yet. Then it's just the normal swinging pendulum, and you'll see because gravity, the effects of gravity have been applied, you see that it slows down over time. So you can use this to great effect in visual simulation here using physics engines and stuff like that. Here's another one where again playing with the movement of the 3D shapes. So here I'm actually doing it sort of the wrong way. I'm pivoting and rotating the actual axis of how I'm rendering rather than moving the shapes themselves. But it was an early way of being able to understand again how I can show, and this is orthogonal. I'm not doing any perspective projection in this rendering. It's very cartoon looking like. So that could be one way to go. It might be actually a little bit simpler. Okay, so I hope you got a basic introduction into the kinds of things that we can go through to basically build this Doom-like world that harkens back to the 80s where there weren't a lot of memory to work with, so we can do it in an efficient way. There's some tricks to do that are kind of cool. So all you have to do is like and subscribe, leave a comment below, let me know that you want to be a part of the course. We need 3 people, and for $15 I'll get the website running, and we can meet, and then you can code with me, and you can create your own 3D rendering engine from scratch using just pure vanilla JavaScript and Canvas. So if you're interested, let me know. Leave a comment below, and I hope to see you in the next video and in the class. So let me pause this video here, and I look forward to teaching you more in the future.